So now this is a PNP bipolar junction transistor circuit that is a current source. So we're going to set the meter to milliamps of current right there. I don't have to move the red probe for anything but high current. I never have to move the black probe, so we don't have to do anything with that. This is an auto ranging meter. If you are using a meter that you have to set the range, set it to a number higher than you're going to measure. But in any case, this is going to be about 10 milliamps of current, a little less than 10 milliamps. And we have about 13 volts at the supply voltage. I think current's going up a little bit because we are generating probably a fair amount of heat in the transistor. So it changed like a little bit. But in any case, now we're going to add this LED. It would be more stable at lower voltages. But there you can see. Now we got 9.73, which again was higher than I got before. But main takeaway is we're slightly less than about 10 milliamps. We'll look at why. And they're 9.72. Plus, we may have a little bit of differences because I bumped stuff and maybe they're conducting slightly better. But there you go. So now we got 3 series LEDs. Remember, we started off with no load at all. We, had, as far as the connection from the transistor to ground, a short circuit originally. I can do that again right there. And then I can go to 1 LED. You'll see 1 LED light up, 2 LEDs, and 3 LEDs. Now, we don't have enough supply voltage to maintain this, but we're still going to do decently all right, as we'll see right here. Adding a 4th series LED, it's starting to go down a little bit. So we need a volt or 2 more to maintain the current we had before. And again, it looks like as the transistor warms up, it's conducting a little bit better. That is a good reason, or kind of a good, without actually doing it, demonstration of thermal runaway. When semiconductors get hot, many of them tend to conduct better, which is a problem if you already have them set close to their limit to begin with. If they start conducting better, they're going to get even hotter and they may overheat. Make sure when you're done with the multimeter to turn it off. So now it looks like we got a pretty good view of everything. This is the PNP Bipolar Junction Transistor. I'm using a 2N3906. Flat side is to the left. If you're looking right on, the left would be emitter, base, and then the right would be collector, but now it's top, emitter, base, and then bottom, collector right there because it's facing to the left, flat side. And there you can see 510 ohm resistor, 5.6 volt Zener diode, that is reverse bias of course, and then a 10K resistor right there. So we have that current path right there. What the Zener diode does, it's going to take away about 5.6 volts when it comes to the base right there, this connection, this node where this all connects. I didn't put a dot there. Some people want a dot, but of course that's connected. So it's going to be 13 volts minus about 5.6 volts. And that's in relationship to this emitter right there. There's a 5.6 volt difference from this and the supply voltage there. So what the emitter is going to do, it's going to drop about 0.6 out of that, leaving about 5 volts at the emitter. 5.6 volts less than the positive supply voltage there, and then 5 volts less than the positive supply voltage there. It's going to let current pass through this way right there, as long as we don't exceed the current needed to keep 5 volts across that resistor. If it's a 500 ohm resistor, as I said before, we got 5 volts across it, we're going to get 0.01 amps of current, which is the same as 10 milliamps of current. I don't have 500 ohm resistors, I don't think, anywhere. I have 510 in my kit. And so that's what I'm using. That's why we got slightly less current right there. And so we got the transistor. Rest of the voltage goes across the transistor and whatever the load is. So when we had no LEDs, we had 8 volts across the transistor there when we shorted it to ground. Of course, when we don't have current flowing, things are going to go haywire. But we need that current flowing to maintain these voltages. So we shorted through the meter. You have to put the current through the meter. And so when I connected both ends, that was shorting it. So this is short circuit protection. This is one way to do that. You set a current source so that it provides more current than the load needs, and the load will limit current after that. But if you accidentally short it, the current's still limited. So hopefully nothing fries. And when it comes to the transistor, so I was probably worried about the wattage, because we're building up kind of a lot of voltage on it, and you know, relatively, but apparently not too bad. 8 volts when we're just shorting it, 0.01 amps, 10 milliamps, 0.08 watts, which is much less than 0.625 watts there. So we're perfectly safe even shorting this. Now, you notice when we added 4 series red LEDs drop about 2 volts each, which totals about 8 volts. That started taking away voltage from these other components there, and thus current started going down. We didn't have enough voltage to power everything at 10 milliamps. You know, we were close. Probably didn't have anything across the transistor and we're just starting to lose a little bit across the resistor when we had 4. But with 6, you know, we had about 2 volts across the transistor, and then 6 across 3 LEDs. I meant to say 3 LEDs, which would be 6 volts, and so on. The LEDs are going to take away the voltage that is across the transistor. Once it starts when the load starts taking more voltage than that away, it'll start taking from that resistor, and current will start going down, as we saw earlier. So, in any case, again, right now, practically no currents flowing. We have the Zener diode and the 10K resistor, a little bit currents going through that way, but it's an open circuit right now, so no currents going over there. It doesn't force 10 milliamps of current. You know, as I said before, if you know, you drop a bunch of voltage here, have very massive resistance there, of course no current's going to flow. Doesn't force current. That's not what a current source does. A current source just provides a certain amount of current as long as there's enough supply voltage to do so. So with lighter loads, we could use a lower voltage and still maintain that current if we so desire. But in any case, that's about it. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.